Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 3C and Mathematics 4. Swedish high school education system. The definition of the derivative. Hi, this is Babak. In this video I am going to solve the following problem for you. Use the definition of the derivative to determine the derivative of the following function. F of x equals to x over square root of x plus 1. I recommend you to pause the video at this point and try to solve the problem yourself. If you do everything correctly, the final simplified answer that you get would be f prime of x equals to x plus 2 over 2 times x plus 1 times square root of x plus 1. Okay, now let us solve the problem. I'm supposed to use the definition of the derivative to calculate the derivative of this function f. So let me write the definition of the derivative first. So f prime of x is equal to the limit of f of x plus h minus f of x over h when h goes to 0. Okay, so what I can do here, I should write limit. I have a fraction here, which is the denominator is h. Instead of f of x, I put this expression, which is my function. So I will have minus x over square root of x plus 1. But for f of x plus h, I need to go to my function f and take x's away and replace them with x plus h. So this x will be x plus h, but I don't need a pair of brackets here in the numerator, so I just simply write x plus h. And for the same thing for the denominator, so it becomes x plus h plus 1. In principle, I should put a pair of brackets around that, but it is not necessary for this case. So what I will do here, this becomes x plus h divided by square root of x plus h plus 1. H goes to 0. Yes? So my goal is to calculate this limit. How should I calculate this limit? This is a little bit tedious, so you need to be careful about the algebra that you are doing. So, for example, to get rid of these partial fractions, I multiply everything by the product of these two terms, yes? If I multiply this on the first term, then this one and that one will be cancelled. This is left and this is left. They have to be multiplied together, okay? And then I have a negative sign. Then when I multiply this by that, this time this is cancelled, and x is left, and this one is left. Okay, so might be I'm making it complicated. So let me write something. The expression that I want to multiply both the numerator and the denominator by is just simply this expression. X plus h plus 1 multiplied by x plus 1. I want to multiply the numerator and the denominator by this expression. Okay? So if I do that, this becomes equal to the limit. The numerator becomes x plus h multiplied by square root of x plus 1 minus x times square root of x plus h plus 1. The denominator should also be multiplied by the same expression, so this becomes x square root of x plus h plus 1 multiplied by square root of x plus 1. H goes to 0. Okay? Now, what I'm supposed to do, if you have seen the previous videos, you have this experience here. Somehow I need to get rid of these two square root signs in the numerator. So the point is that I copy and paste everything and I multiply the numerator and the denominator by the conjugate of the numerator. Yes? Okay. So what I do, assume that I have copied and pasted this one, so in front of it I multiply it by the conjugate of the numerator. So the conjugate of the numerator is x plus h square root of x plus 1 plus x square root of x plus square root of x plus h plus 1. And then I also multiply the denominator by that. So I multiply and divide by this expression, yes? Yes. So if I ask you what is this, you would say this is 1. So I am just multiplying this expression by 1, which is exactly the same thing. But the point is here, the point here is that if I multiply this by that, it makes a conjugate pattern, so I can use the conjugate identity. So this becomes the limit. The numerator, when I multiply this by that, it becomes the first term to the 2 minus the second one to the 2. But this one is a product, so if I want to raise it to power 2, I have to raise this one to power 2 and this one to power 2. When I raise this one to power 2, I will have a power of 2 here. When I raise this one to power 2, a square root of x, a square root sign is gone. Yes? So what I get is x plus h to the 2 times x plus 1 minus, if I raise this one to power 2, because that's a product, x should be raised to power 2, which becomes x squared. This one raised to power 2 which, becomes x plus h plus 1. So it becomes x squared times x plus h plus 1. And the denominator is a little bit lengthy. I just multiply them, so you see I have to multiply these expressions together. But these two expressions can be written under one square root sign, so I would write one square root, and then I would write x plus h plus 1 multiplied by x plus 1. What I have written here is the product of these two, and this h is here, and then I have to put this in a pair of brackets and put them in front of it. Okay, so this becomes x plus h times square root of x plus 1 plus x square root of x plus h plus 1. Okay. Okay, now what can I do? I have to expand, h goes to 0. Now I have to expand the numerator, but keep the denominator as it is. So for the denominator, you shouldn't be worried. I just copied and paste this one over and over again. So, but for the numerator, I have to expand this. To expand this expression, first I use the quadratic rule to raise it to power 2, so it becomes the first one to the 2, 2 times the first one times the second one, and the second one to the 2, multiplied by x plus 1. And here I just simply multiply minus x squared inside, so it becomes minus x cubed minus x squared h minus x squared. And the denominator is just a copy and paste of the denominator here. Hopefully I can make it right without having to write it again. Let us see how it works. Copy. Yeah, so you see I'm just copy and pasting here the denominator. But h goes to 0. Oh, sorry. H goes to 0. And then I have to complete my expansion in the numerator, so I have to multiply these two polynomials together. So it is easy to do that. It becomes x cubed plus x squared. So what I'm doing, I'm taking this, multiplying it here and there. I take this one, multiply it here and there, and then I will take this one and multiply it by these two terms. Okay, so let me just do it quickly. So it becomes x to the 3, x to the 2, plus 2x squared h plus 2xh plus h squared x plus h squared, and then at the end I have minus x cubed minus x squared h and minus x squared, and the denominator is actually as before. So let me paste it again here. So here h goes to 0. Okay, so I don't have enough space here, so let me move everything to the other page. I hope that I have done it correctly. No, unfortunately this is not working. Let me do it once more, sorry. Yeah, that's better. Copy, we go to the next page. So let me paste it here. Okay, so that is the limit that I want to calculate. Okay, now if I change the color, so you see here x to the 3 and x to the 3 are gone, x squared and x squared are gone here. So what is left for me here? I have 2x squared h, I have x squared h minus sign here. So what is left for me in the numerator is the limit of just one single x squared h. Then if you see, I have this term, and this term, which are not similar. So I have to write all of them. So this becomes plus 2xh plus h squared x plus h squared. And then I have to copy and paste the denominator as before. So let me make it big enough. Yes, so here I will go here and try to do the same thing here. So I will take this one, copy, and put it here. Yes, but then you immediately realize what to do. So you can see that in the numerator I can factor h out between these four terms. I can pull an h out. It becomes x squared plus 2x plus hx plus h, and then the denominator is actually as before. Yes? So this is my denominator again. This time h goes to 0. Yeah, sorry, h goes to 0 all the time. But then here, this h and that h are cancelled. And then when h is cancelled from the numerator and the denominator, and probably my problem is solved, so it means that now I am able to plug h equal to 0 into the remainder, or into what is remained after cancellation. Okay, so this is not something that hard, so what I do, I drop the limit sign. My point is to put h equal to 0. When I put h equal to 0, this is 0, this is 0. In the numerator, these two terms will survive. So this becomes x squared plus 2x. And let us see what happens for the denominator. Yes, but the denominator, when I put h equal to 0, this becomes x plus 1. This is also x plus 1. So this becomes a square root of x plus 1 to the 2. Yes, and then when I put h equal to 0 here, this becomes x square root of x plus 1. If I put h equal to 0 here, this is also x square root of x plus 1. So if I add them, it becomes 2x square root of x plus 1. Yes, so this becomes times 2x square root of x plus 1. Okay, so in principle, if I ask you what is a square root of x plus 1 to the 2, you should say it is absolute value of x plus 1. Yes, but absolute value is not needed here, because if you see the function is defined in this way, it means that this function should be defined in the first place. So x plus 1 is a positive number. And when x plus 1 is a positive number, why? Because if it is negative, this is not defined. The square roots are defined only for positive non-negative numbers, but of course 0 cannot happen either, because this appears in the denominator. So we know that if this function is going to be defined, x plus 1 is strictly greater than 0, and if an expression is strictly greater than 0, you don't need the absolute value sign. This is simply equal to itself. If a number is positive, its absolute value is equal to itself. So here, if I want to continue, in the numerator I can factor an x, it becomes x plus 2. Factoring is because I want to write this in the simplest possible form. And instead of this one, I write absolute value, but absolute value is not needed because of my explanation, so it becomes just simply x plus 1. And then you have a 2, then you have x, then you have a square root of x plus 1. But then what you see is that this x and that x are cancelled, so what is left in the numerator is simply x plus 2, and what is left in the denominator is a 2, an x plus 1, and a square root of x plus 1. Yes, so finally we realize that the derivative of the function that we were looking for is simply x plus 2 divided by 2x plus 1 square root of x plus 1. This is the solution to this problem. Okay, so I hope that this video was somehow useful for you. You can find the link to download this PDF file below this video in the descriptions. Until the next video, be safe and goodbye.